You know, for decades, there's been this nagging problem right at the heart of cosmology. The better we get at measuring our universe, the more it seems to be arguing with itself. And we're not talking about a simple rounding error here. This is a deep, fundamental mystery about how our universe even began. So in this explainer, we're going to dive into a pretty radical new idea that suggests this cosmic glitch, well, maybe it isn't a glitch at all, but a clue to a much deeper, dual-natured reality.
So what's this big contradiction all about? To really get it, we gotta look at the problem the way cosmologists do. And it all comes down to a clash between two of our most trusted ways of measuring the cosmos.
Okay, so picture this. On one hand, we can look deep into the past, at the baby picture of our universe, that faint afterglow of the Big Bang called the cosmic microwave background. And that ancient light tells us the universe is expanding at a rate of about 67.4. But when we look at stuff that's much closer to home, modern galaxies and exploding stars, we get a totally different answer. A faster one, 73.0. See the problem? Two different views, two different numbers.
And look, this isn't something we can just brush off. The measurements are so precise now that their error bars don't even overlap. This is what scientists call a 5 sigma problem, which basically means there's a 1 in 3.5 million chance that this is all just a random fluke. Our best model of the universe, called ΛCDM, is completely stumped. It just can't explain this without tacking on some new, unproven physics.
But what if the problem isn't our measurements? What if it's not even our model? What if the problem is our most basic assumption that the whole universe started from one single thing? This is where the source material we're looking at proposes something, well, something pretty radical.
The idea is called the dual caustic. It says, forget the single point. What if the universe bursts forth from two coexisting fields, right from the get-go? One field is called light, or Ayat. The other is a field of sound, or Hayat. And it's really important to get this. These aren't just poetic names. The model treats them as real, actual physical fields that were there from the very beginning.
And just to be absolutely clear, the source material goes out of its way to say this is not a metaphor. It's presented as a literal two-field cosmology that's built to work with what we already know from Einstein's equations and quantum field theory. It's a genuine attempt to describe the physical reality of how our universe was born.
Okay, so the big question is, how does this actually work? How could having two fields at the beginning solve the Hubble tension? How do you get two different speeds from one universe?
This table really breaks it down for us. You've got two fields, each with a totally different job. First, there's the light field, also called phi. This is the main engine, the thing that drove that initial smooth expansion of the universe. And it's what we're picking up when we look at the cosmic microwave background. But then you have this other field, the sound field, or chi. It's this quieter, lighter partner that's kind of in the background at first. But, as we'll see, it plays a huge role later on.
So here's the magic trick. It all comes down to what our telescopes can see. When we look at that ancient light from the CMB, our instruments are only sensitive to that first, primary light field. But when we look at how galaxies are clustering and moving around in the modern universe, our measurements are picking up the gravitational pull of everything. That includes both the light field and the sound field. And since more energy means a faster expansion, voila, you get two different measurements.
But the model gets even weirder, and honestly, kind of beautiful. It claims that this duality isn't just a random accident. It suggests this two-sided nature is actually imprinted on the fabric of the universe with a very specific mathematical signature.
And that signature is the number 19. Now hang on, I know you might be thinking, numerology, right? But stick with me, because the model actually tries to ground this in real physics.
So why 19? Well, the model breaks it down into 10 plus 9. The number 10 is tied to that smooth, coherent structure of the cosmos, while 9 is linked to this resonant, more dynamic quality. And here is the truly wild part. The model proposes that this 10-to-9 ratio isn't just philosophy, it's a real physical value that's encoded in the math describing how these two fields interact. It's a bold attempt to connect a deep concept to a hard physical number.
Now, this is maybe the most crucial part. This whole idea isn't just a fun thought experiment. It makes concrete predictions that we can actually go out and test. It predicts a very specific wobble in cosmic sound waves, a unique fingerprint in the CMB, a precise value for another key cosmic number, and even says the Hubble constant itself should change depending on how big a patch of space you're looking at. The best part? Telescopes like DESI and Euclid are designed to look for exactly these kinds of things. So this model will either be confirmed or will be proven wrong by the data. That's real science.
So, let's put it all together. How does this dual fields idea neatly resolve the Hubble tension?
And the answer is actually pretty elegant. The Hubble tension just stops being a crisis. Instead, it becomes the exact evidence you'd expect to find if you were looking at a dual-natured universe with different kinds of tools. It's not a bug, it's a feature. It's a clue that we've been right all along, just not seeing the whole picture.
This chart just sums it all up perfectly. That lower measurement from the early universe, the 67.4, that's just the energy from the light field. But that higher, later measurement of 73, well, that's the energy of the light field plus the extra contribution from the sound field. The difference between them is literally the effect of that second field finally making itself known.
So what's the big takeaway here? This dual caustic model doesn't just offer a clever fix for a data problem. It actually reframes the whole conversation. It asks us to seriously consider that maybe, just maybe, the universe has a kind of dual identity baked in from the very start.
The source material really brings us home with this final thought. The Hubble tension isn't a crisis, but it's evidence that we're sampling two different aspects of a single, unified origin. One command that started it all. In this view, the physics of light and sound are just two distinct echoes of the same creative event.
And that kind of leaves us with a fascinating final question, doesn't it? Whether this particular model turns out to be right or wrong, it pushes us to think bigger. If it's possible for the universe to speak in dualities, from the weirdness of quantum particles to the expansion of the entire cosmos, you have to wonder, what other truths are out there that we're only half hearing?